from 2025 AMC 12A. And for being problem 17, this one seems a little bit on the easier side, so let's see why. The polynomial z plus 2i, z plus 3i plus 10 has three roots in the complex plane where I is the imaginary unit. What is the area of the triangle formed by these three roots? So let's just take a look at this polynomial. So basically the roots are the z such that when we have this 3i plus 10 equals 0, the roots are just all z such that this is true. And immediately looking at this equation, we can find that there's some sort of symmetry because there's z plus 1, then z plus 2, then z plus 3. And so what this led me to do is let's just think about how we can take advantage of this. It's not exactly symmetry, but it's something that's nice. But can we turn it into something that's a little useful? And the way I did that is by setting u equals z plus 2i. And so we're just going to make that substitution. And so that gives us this one is u minus I times u plus I plus 10 equals 0. And this simplifies very nicely. So we get u squared plus 1. Just doing these outer terms gives us that, times u plus 10 equals 0. So this simplifies to u cubed plus u plus 10 equals 0. And so now we look like we kind of stuck and hit a crossroads. And so whenever you're given a polynomial that's like not a simple quadratic polynomial and you can't just use a quadratic formula, I always advise you to use the rational root theorem. And the rational root theorem says that if there are rational roots, at least in this example, they're going to be of the form plus or minus 1, 2, 5, or 10 divided by 1, since that's the coefficient. So since the coefficient of this is 1, so we don't have to worry about that right now. The roots of this, if there are rational roots, they're going to be of the form plus or minus 1, 2, 5, or 10. And so just looking at this, well, 1 doesn't look like it's going to work. 1 plus 1 plus 10 is 12. Minus 1 plus 10 is 8. 2, well, 8 plus 2 plus 10 is 20. But minus 2, that gives us minus 8 minus 2 plus 10 equals 0. So let's write that down. U equals minus 2 is a solution. And so just using rational root theorem and trial and erroring all 8 of these different combinations is going to lead us very quickly to an answer. So u equals minus 2 works because that means we get minus 8 minus 2 plus 10, and that does equal 0. So that is one solution. And since we have one solution already, we can use division to factor it out. And so I'm going to use synthetic division here since this does have coefficient 1. So you get 1, 0, 1, 10. And I like to draw a line here since this is going to be the remainder. So this one, we always just chop it down. Then this becomes minus 2. Then minus 2 times minus 2 is 4. So we just put the 4 here. Then this becomes 5. And then, I think I did this a little bit wrong. It's not how it's supposed to be. So this one is minus 2 here. And then the 4 goes here. And since now we have this is 5, then minus 2 times 5 is minus 10, so this leaves us to 0. There we go, that's correct. And so the resultant polynomial is u squared minus 2u plus 5 equals 0. And just by looking at this, you can tell that there's no easy factors here, so we're just going to use the quadratic equation. U equals minus b, which is this, plus or minus square root of 2 squared minus 4 times 1 times 5, all divided by 2, which is equal to, well, 2 plus or minus, and since there's a 4 here and a 4 here, I can basically factor that out, and we get 2, 1 minus 5 over 2, which that's really nice because the 2's all cancel. We get 1 plus or minus square root of minus 4, which is just equal to 1 plus or minus 2i. So those are the second. So we get our total ones are u equals minus 2, u equals 1 plus or minus 2i. So let's keep this in mind, and now let's plug this in for z. So I'm going to come back up here. U equals minus 2, u equals, what was it again? It was 1 plus or minus 2i. And so now if this is the substitution we used, u equals z plus 2i, so that means z equals u minus 2i. And so now we can just plug this back in, plug in u to find what z is. So the z for u equals minus 2 is going to be minus 2 minus 2i. Then z for, let's choose, this is going to be 1 plus 2i, then this is going to be 1 minus 2i. I'm going to do this one first. So since u is 1 plus 2i, then now there's a minus 2i, z is just 1. And now 1 minus 2i is equal to 1 minus 4i. And so now we have each of the three roots. And what do we need to do? We need to find the area of the triangle that are formed by these three roots. And now there's a lot of ways to do this analytically, like you could try taking the determinant or the cross product of turning these into like vectors and doing all that. But I think, at least in this problem, there's a very easy way. You just draw this out. Either way, you should draw this out first of all. And so 1, 2, 2, 3, 4. Then 1, 2, 3, 4, 1, 2, 3, 4. And so just drawing it out, this is z equals 1 here. Then minus 2 minus 1, 2i is going to be right here. Then 1 minus 4, 1, 2, 3, 4 is right here. So you get this triangle that we want to find the area of. And this triangle is actually pretty lucky for us here because it's not too hard to find the area of this triangle. Because this, let's call this the base. This base has 1, 2, 3, 4. This base is of length 4. Then this is going to be the altitude. So let's find the length of this altitude here. So this altitude right here is 1, 2, 3. So it's 3 since these are going to be exactly perpendicular. We could have figured that out from these coordinates too. You could have turned this into minus 2, minus 2. Then this would have been 1, 0. Then this would have been 1, minus 4. And if you plotted this, which is basically what I did here, you would have figured out the same thing. So we just get 3 and 4. The area of the triangle, 1/2 times 3 times 4 equals 6. So that's our answer, and so A. So the key part here was just finding this u substitution, u equals z plus 2i, which lets us turn this nice like arithmetic progression into something that's actually symmetric, which makes everything factor super easily. Like when I first tried doing this, I just tried bashing this out, and that was a lot of work. And I don't think there's really a need for doing that work because after bashing it out, I was still completely confused. So finding this key substitution, which saves a lot of time, but also gets you to the right answer a lot faster.